afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are talking about growth and decay. We are spinning some tunes from the rapidly selling Dave's Faves CD produced by the great Darby Foster. So, let's get to it, shall we? Okay, just a couple of examples. We'll come back to Come With Me by the Congos. Love that song. Two examples. We're going to talk population growth, boys and girls. Got a farmer. He's monitoring an insect plague. And he notices that the area affected by the insects is given by A sub n equals 1,000 times 2 to the 0.7 hectares, where n is the number of weeks after, that's important, after the initial observation. Now, we are not going to draw an accurate graph because in order to draw an accurate graph, we have to know how to handle 0.7 to the n power. It would just take too much time, and we would always do this with a calculator. We could plot some points and do it pretty well, but it's a bit of a waste of time. We know how to graph these, so we're going to move forward. But they want us to use our graph to estimate the time taken for the affected area to reach 5,000 hectares. And we're going to check using logs and using technology. So really what we're going to do is we're going to solve this using logarithms. So we need to know when the area affected area is 5,000. So we're going to replace A sub n with 5,000. 5,000 equals 1,000 times 2 to the 0.7 n, okay? And all we need to do is solve for n. So divide both sides by 1,000. And we get 5 equals 2 to the 0.7 n. Our variable is in the exponent, so we must use logarithms. And since this is base 2, we might as well use a log of base 2 because it doesn't matter what base we use. Log base 2 of 5 equals log base 2 of 2 to the 0.7 n. And the reason we're going to do that, and maybe we don't even have to show this step, is log base 2 of 2. If the base is the same as the argument, it's always equal to the exponent. So I have log base 2 of 5 is equal to 0.7 n. And then if I go right here, running out of room, I guess. Actually, I don't want to do that. I'm going to say that log base 2 of 5 over 0.7 is equal to n. And then we will go ahead and use our calculator to calculate that. Log base, let me get a calculator page here. Go to my log, control log base 2 of 5. And I believe that's divided by 0.7. Let me check. Yep. Divided by 0.7 is going to equal 3.317. So let's write that down. So that's approximately equal to oh my gosh, my short-term memory. 317, was that it? Yeah, 317. Rounded to 3 sig figs, that's about 3.32 weeks, which is a fine answer. But if we wanted to know how many days, we would take, that would be 3 weeks, and then 0.32 times 7 days, since there's 7 days in a week, obviously, whatever that is. I think it's about 2. Yeah, 0.3 is 2.1, so it's 3 weeks and about 2 days. We can also solve this by graphing. This would be an exact answer here. This is an estimate. We can also get an estimate by graphing. So we are going to graph that function. And so I'll go to my graphing page. And the first thing I'm going to do is graph my function. So 1,000 times 2 to the 0.7x, and I graph it, and you can't see it, which is no surprise, because we're trying to figure out when it's going to be 5,000. And when n equals 0, it's 2 to the 0 is equal to 1, and 1,000 times 1 is 1,000. So we know your vertical axis is going to be 1,000, and we figured out that it was about 3 weeks. So we can with that knowledge, we can set our window accordingly. Menu, window zoom, and I'm going to go to window settings so I can do it myself. My X minimum, I'm just going to go to 0. I think 10 is good, and I'll make the scale 1. Y min, I only need to be 0. I want to know when it's 5,000, so maybe I'll go to 10,000 with a Y scale of 1,000. See how it looks. Ooh, and there's our graph. And now I just need to graph the function 5,000 and see where they intersect. That represents the number of acres. Boom. Find the intersection point. Menu. Analyze graph. Intersection. Boom. Boom. There we go. And it shows 3.32 weeks, which is our solution. I just don't have my calculator set. That's actually 5 times 10 to the third power, which is indeed 5,000. So let's get a picture of that. So we have it as our solution, confirming our findings with a graph. Okay, and we'll move it over here. And of course, if you were using a graph on an exam, you would need to sketch it to show us how you found that solution. One more. We got 5,000, I think that's pounds, to invest in an account that pays 5.2% per annum. So that's per year, compounded annually. Oops, I don't have my pen. So PA is per annum, and of course annum means year. Okay, and it's compounded annually. Find using logarithms how long it will take for the investment to reach 20,000. Well, we have to realize that if it's compounded annually, that the amount, I'll just call it A, is going to be equal to the principal investment P times 1 plus R to the n power. Why 1 plus R to the n power? Well, R is the rate, and the rate is 5.2%. And we're not looking for the amount of interest, we're looking for the total investment. That's why I need to put in a 1, because a 1 written as a percent is equal to 100%. So that means that I'm going to be able to calculate the interest. I'm going to be adding the interest because it's 100% plus the interest rate. So I'll be adding the interest to the principal, thereby giving me the total amount. So we're going to do substitute in 20,000 is equal to principal amount of 5,000 times 1 plus 0.52, 5.2%. Hopefully you know this is equal to 0.052. So that's going to be 1.052 to the n power. So I need to solve for n. 20,000 divided by 5,000 is, of course, 4. So that equals 1.052 to the n power. And let's see, let's go ahead and take log base, well, that would just take care, I'm not going to do that, 1.052. I'll just go ahead and take the log of both sides. What I was thinking is, well, I can make it a base 1.052, but that's weird. So log 1.052 to the n, divide both sides, and then, no, not divide by both sides yet, because I haven't written it. Bring the exponent down as a coefficient. Then I divide both sides by log 1.052 equals n, and we'll go to our calculator. So log 4, go back here, we'll do log of 4. Of course, that's base 10 now since we didn't stipulate, over log 1.052. Hey, he remembered. That's amazing. And we end up with something we're going to have to interpret 27 point something. So you got to be careful with this interpretation now, because we got n equal to, or approximately equal to 3 sig figs, 27.3. So your answer is not 27.3 years, because the interest is compounded annually. So it's compounded at the end of the 27th year, and then we have to wait, which is going to, since there's a 0.3 here, that's going to be less than the 20,000 that we're shooting for. So it won't be until the 28th year that it will reach, the investment will reach a value of 20,000 pounds. All right, hope you enjoyed that. We're going back to Dave's phase to take us out. And with that, I am out.
Afraid to lose control, caught up in this world. I've wasted time, I've wasted breath. I think I've